So, good morning, folks. I am Pranay. I am one of the co-founders at SigNoz, and I'll be talking about unified observability with SigNoz and how you can use OpenTelemetry and harness it to monitor all of traces, metrics, and logs in a single app. Before I dive deeper, as a quick introduction about myself, I'm one of the co-founders and maintainers SigNoz. Before this, I was working in product at Microsoft and have been developer myself in the past. So a lot of experience in working in products and building technical products. Just aside, I love reading, so I read a lot of books and also like trekking. So here's a image of me with my co-founder Ankit. Not was not my co-founder then, but we were trekking in the Himalayas in the India, and that's where we sort of met, right? So yeah, that's a brief about me. SigNoz, as I mentioned, is an open source observability platform. We are a product where we have metrics, traces, and logs in a single application, and it is completely OpenTelemetry native. As of now, we launched it around 2021, and it has been widely adopted by the community now. We have around 18,000 plus GitHub starts, 5,200 plus members in the Slack community, and 100 plus 50 plus contributors from across the globe. The product is being used by users from across the world. And yeah, we have received lots of good feedback from the community on what type of open source product should be built and why it is important to have like single source of truth for metrics and traces and a log in a single application. So that's one area where we'll focus on in this talk. As you guys know, open source and OpenTelemetry has been a game changer in the world of observability, and especially in the context of this conference. I think open source observability is the future. We strongly believe that, and that is one of the areas where we are looking to spend more and more time and make that future as a reality, right? Because if you think about it, observability products are fundamentally used by developers, and there's no reason why, if there is as good product in open source, that it should be preferred compared to a proprietary product. So that's where we started SigNoz, and in this talk, still short of share a brief on the journey we took there and what are the areas we are currently focusing on. So yeah, I think the first point which I'd like to share is around OpenTelemetry. So OpenTelemetry as a project was started around 2021, and it has been a paradigm shift in the observability landscape. For people who are not aware of OpenTelemetry, OpenTelemetry is fundamentally a set of SDKs and libraries which help you send telemetry data. And it also has an OpenTelemetry collector, which helps you send data from different sources, collect it, process it, and then export it to different destinations, right? So it's essentially acts as a exporter and an agent basically, which runs in different platforms and helps the organization send the data to the observability backend. So OpenTelemetry uses that. Somebody can use OpenTelemetry to send data and use a observability backend in observability backend like SigNoz in the end to visualize that OpenTelemetry data, right? So that's where we come in. So anybody can use today OpenTelemetry with SigNoz and just build a complete open source solution based on OpenTelemetry and SigNoz. When we started, as I mentioned, we started in 2021, and that was the time when OpenTelemetry was just getting started. For people who don't know, OpenTelemetry started with merging of a couple of projects like OpenCensus and OpenTracing. And when we're starting the project, it was an early bet that we thought that, hey, OpenTelemetry should be the way things should be done. And that has been sort of the reason for a lot of tailwind behind SigNoz. So we built SigNoz as an OpenTelemetry native product where that's the only agent we support to send, like that's one of the main agents we support to send data to us. You can use any OpenTelemetry docs and receivers to send data to us, and we have default support for it, right? So I'll get into this much later in the talk, but essentially OpenTelemetry has been a big paradigm shift in the whole ecosystem, right? And why is OpenTelemetry important? Essentially, it has now today the second highest, fastest growing project in CNCF, and this is just after Kubernetes. And we all know how much instrumental Kubernetes has been in changing the whole landscape, right? So it is one of the most important projects in that respect. And what it enables you is to enable a open source instrumentation without any vendor lock-in. It is now soon we are seeing a lot of companies, especially any bigger companies who is instrumenting and starting with a new observability stack. They're by default going to OpenTelemetry because that is becoming now the default stack for observability. And that's where we come in, where SigNoz, we have built SigNoz to be an OpenTelemetry native product. And I'll get into what we mean by OpenTelemetry native product. So we chose essentially to build SigNoz as an OpenTelemetry native product. What that essentially means is that it supports all OpenTelemetry receivers by default. Any receiver which you see in the OpenTelemetry collector contrib repository, should be able to use that to send data to us. We have by default docs and instructions assuming OpenTelemetry. So it's not a second-class citizen like many other products where you have to start with their agent. And if you want to do with OpenTelemetry, you have to hold your nose like this. So that's not the case. It's like you just hold your nose like this if you want to instrument your apps with OpenTelemetry and send your data to SigNoz. So, and that has enabled us to get a lot of interest from users and customers who want to adopt OpenTelemetry. We're building a lot of features around OpenTelemetry semantic conventions and deeply using this. So the main thing which OpenTelemetry provides is a new data model, which is open source, which everybody has agreed to send data based on. And we use that to send data based on those semantic conventions, right? And I'll show you a couple of new features which we're building around using that OpenTelemetry semantic conventions and how it can be used to get much deeper insights into your product. So that's where we focus on. And yeah, maybe I'll take a pause. Yeah, and at SigNoz, we as I mentioned, we treat OpenTelemetry as a first-class citizen. So there's no OpenTelemetry data is not charged differently, as we'll see in like a couple of slides, right? So if you send OpenTelemetry data to us, it is like the first-class citizen. This is the thing for which SigNoz was built for, and that's what we essentially mean by OpenTelemetry native, right? So some of the features which we have been working on around messaging queue correlation. So we use open data being sent by OpenTelemetry instrumented applications, and we correlate with the data in the messaging queues. And that's how we are sort of building the first feature around messaging queues, which is native to OpenTelemetry. So this is an example of how we are doing correlating Kafka. So you can answer questions like, hey, like what is the time it took from application or like request going from service 1, which is the producer service, to service 2, which is the consumer service, and what's the lag there, right? And here we have leveraged OpenTelemetry conventions to build out this dashboards out of the box. Because now we have a standard data model which we can rely on. So anybody who is instrumented their applications with OpenTelemetry and can now sort of start getting this data in SigNoz out of the box. So this is example of one of the features which are building for leveraging OpenTelemetry semantic conventions. I think the other example is just that why is OpenTelemetry native backend important, right? So there's some vendors, especially like Datadog, who treat OpenTelemetry's metrics very differently. For example, they don't consider it at par as as a standard metric, and the charge is as a custom metric in Datadog, right? And Datadog custom metrics are charged very heavily. So this is a scenario where we don't want to have. We want to have all type of data to be OpenTelemetry data to be treated as first-class citizen, and not saying that, hey, like if you're not sending us data in the format we want, which is in many proprietary products cases, their proprietary agent, this will be charged differently or this will be treated differently. We know a couple of other products where they they have a different layer for OpenTelemetry, and it's not part of the core experience. So which is not how we think that should be. Because OpenTelemetry is fundamentally changing how people are using and is rapidly getting adopted. I think at this point of time, if anybody is choosing an observability tool, they should by default look for OpenTelemetry native support. So that's one of the things which we have learned from our customers. Many customers and users flock to SigNoz because of the deep native support and also sort of our roadmap on building deeper into it. So that's why one of the main points why we think OpenTelemetry native support is important. I think the second key piece is around correlation, right? So OpenTelemetry is unique in the sense that it now supports all the three key signals around traces, metrics, and logs. They're in different levels of maturity, but I'm sure as the product is very active, the support will get much better and better. They are also adding new signals like profiling. So now we have a common format where you can send data of different types, and the three key pillars around metrics, traces, and logs to OpenTelemetry, right? And using this, the key thing which you can do is to enable correlation. Now you can think that, hey, why is support for all the three signals important? I think what we have seen working with our community and with our users is that there's a sort of S curve of adoption in observability also. So as in any technology cycle, there's a S curve of adoption that first early adopters come in and then rapidly becomes active. Similarly in observability, and this is like a crude representation, but to think roughly about it, the way we think it is that, hey, when people start, they start with logs, and then they start getting basic understanding of what their app is doing, etc. But as they mature in their journey, they definitely start thinking about metrics that, hey, how should we, logs are becoming too much data to handle. How can we aggregate this data and understand it in a better way? So that's where metrics come in. That so essentially metrics are nothing but an aggregation on top, right? Like you can see in terms of, so rather than sending logs for each of the things, you can just send a point data, and then it becomes much easier to sort of send alerts on top of that, plot dashboards based on this, etc. So people start with logs. When their scale becomes bigger, they eventually have to go to metrics. And after the metrics story is also solved, like they have good understanding of metrics, they realize that, hey, just understanding metrics is not enough. You need to be able to understand how services are talking to each other, right? And especially in a world where we are using microservices, distributed tracing, and APM, which is powered by distributed tracing, becomes very important. So that's why I think choosing a framework which supports all the key signals is very important, because it gives you flexibility to scale as your organization matures. If you choose a backend or a framework which only support, for example, logs, it becomes very difficult to you when you start adding metrics and traces, because then you have to start choosing multiple tools, and then correlation across them becomes very difficult. We have seen many users and community ask that, hey, we have a plethora of tools in our organizations. Different teams use different tools. Different teams use different tools for different use cases. So one tool is used for logs, one tool is used for metrics, one tool is used for tracing. Now, how do I correlate across them, right? Because now these are siloed system. It becomes very difficult for them to sort of make a coherent sense out of it. And that's why I think being able to correlate across them and being able to see them across in a single pane is very important, right? So if you think about it, why it is important, right? From a business perspective, correlation is very important because it helps you solve issues faster. If you have a burning issue, if you can correlate across signals, you can figure out issues faster and then solve it. And these three signals provide different views of what you're doing. So metrics provide a quantitative measurement of what things are going on. For example, CPU uses, memory uses. Logs provide a detailed record of events, while traces have this ability to show what's the flow looks like across services, right? So it doesn't, how a request goes from different services and how it gets impacted. Just to take an example, if you have a spike in error rates, right? And that's something which is shown by metrics, you can go and find relevant logs, which can help you solve this problem, or you can go down and go to traces and try to solve this problem, right? If these are in different tools, it becomes very difficult to solve them quickly. And also correlating across different data provides you context, especially if it's important, if it's microservice architecture where there are different services and the request is traversing across them, right? So correlating across signals helps you get context on them, and that helps you essentially reduce MTTR. So that's why in our experience, choosing the observability backend which supports all the three signals is very important. And I think as OpenTelemetry is now providing a unified data model for how these events should talk to each other, I think it's a no-brainer why people should not choose a tool which supports all of them, right? And this is something which we think organizations should consider when they're choosing an observability tool, because if even if they are okay with just logs today, if once they mature, they would essentially need to have this support. So I'll show what we mean by this in a quick demo. So imagine you are in a service and you're just monitoring latency of that service. And then you just see a spike here. You want to understand what's going on here. So with SigNoz, you can, or any other tool which has all support for logs and traces, right? You can go to view logs and see what are the logs which are fine, or you can go to traces and see what's happening there, right? So let's just explore the traces path so you can see what are things were there, which traces which were responsible for this high, and then you can go to see the details here, right? And then suppose you saw that, okay, these traces look fine. You can go back and then you can again go here and then go to see the logs which are responsible for that. And that gives you a lot more information that, hey, like what's the type of logs here? What's the severity of these? And like, what more can I know there, right? Now, if you see the logs and in SigNoz, now you can see the overview of the logs. You can see all the parameters there. What is the context of this log, like which logs came before these, logs came after this. So all this is useful information. And I think what's even more interesting is you can go ahead and dive deeper and see exactly how the nodes perform or how the machines in which these logs were produced is performing, right? So you can get data around node CPU. You can get data around, say, node file system users, right? And then you can, for example, see, hey, like when the trace was having high latency, this node was maybe using a lot of CPU, and that may be the reason for high latency. So that's a very relevant information which you can now go down and deep down to understand like what that happened. And having this in like a few clicks as I shown, right? So go from service metrics to logs to like the metrics, I think is super important for any team to solve the issues. And then you can see correlated metrics like, okay, I see nodes, but what's happening with individual pods which are detecting these logs or services? And then you can dive deeper from there, right? So this is sort of the metrics view of like you can get inframetrics right out of the box here. And then you can also see, because logs is also correlated to traces, you can expect this in context of a particular trace and say that, hey, like what's happening here and how you can solve that. And you can also go from here to related logs and then be able to see what's going on. So that's why we think that correlation is super important, and that's one area we are focusing on in SigNoz to correlate across metrics, trace, and log, and provide that in a single app in a very unified view, right? I think the second feature which I want to share is around the messaging queues feature, which I talked about, where we are using OTel native data format to show you the correlation between messaging queues. So you can just go and click a particular data point, and then this will show you at that point of time what was the P99 latency for service 1, service 2, and what was the average message size, and what was the throughput, and you can understand what's going wrong here, right? And this you get out of the box. You don't have to do anything. You just have to instrument your services with OpenTelemetry, and then you will start getting that. So yeah, I think lots of interesting things which we think can be done as OpenTelemetry is unifying the overall landscape of observability. So yeah, as I showed earlier, going from logs to inframetrics will help you resolve issues much faster. Similarly, you can go from traces to logs. And that's why I think correlating across signals is critical. Yeah, so those are like the key points which we have seen in our interaction with the community and with the customers. And those are the areas where we are diving deeper into at SigNoz. I think to summarize, we think that OpenTelemetry is a paradigm shift in the area of open source observability. It's critical that we choose, like any organization which is now choosing new observability stack, chooses the OpenTelemetry native backend, so which can help you leverage OpenTelemetry better and not treat OpenTelemetry as a second-class citizen. We expect that there will be a lot of more innovation around the systematic data model, which OTel has now provided. People are building more, generating more test cases out of the box, generating more LLM observability out of the box. So there's a lot of innovation which this common data model is unlocking. And I think anybody who is choosing an observability product now should be making a choice which can help them participate in that. And as I mentioned, being able to correlate across signals is critical. Choosing an observability platform that works across all the signals will help you get insights faster and then correlate across them much faster. And as we are seeing recently, products like ChatGPT and LLMs are getting more powerful. I think any product which can leverage more and more data sources can provide insights much faster. And that's why choosing a backend, observability backend, which has all the key signals is will be very important. So yeah, I think that's what I had from my side. Happy to chat more with what you guys think in the chat. But yeah, thanks for listening to me. And if you want to learn more about SigNoz, we have an active open source community. You can join our Slack community, or you can check out our repo. Or if you try the product, and if you face any issues, you can just reach out to create an issue in your repo. So that's about us. This is my coordinates if you want to reach out to me. Thanks a lot.